Okay, let's look at a little bit more advanced example of secant functions. So again, we talked about this already. Our function is in the form of a secant bx minus c plus d. And well, this is telling us how to. We're going to express it in the form, we have to make sure it's first in this form. We got to identify the stretching or compressing factor, identify the B and determine the period, identify C and determine the phase shift, draw y equals secant bx, but shift it to the right by C over B and up by D. All right, so let's see. Oh, and also sketch the vertical asymptotes. So we have 2 secant pi over 4 x plus 1. So first of all, it's not in the correct form. So that's what we're going to do first. We're going to put it in the correct form. So we have y equals 2 secant, and we're just going to multiply this pi over 4 through. So we're going to get pi over 4x plus pi over 4. Notice there is no d. Okay, there's no d. There's just a b, and a c. So let's name them. So our a is 2, and our stretching factor, of course, the absolute value of 2 is 2. Our b is pi over 4, and our period is 2 pi over 4. So we get 2 pi times 4 over pi, which is 8. So our period is 8. This one length is 8. Okay, our C is actually negative pi over 4. Why is it negative? Because if we go back and look at the formula is minus C. So we have plus C. So that means we have to have the opposite sign. So it's a negative pi over 4. So our phase shift, we'll just put it as PS, will be negative pi over 4 divided by our B, which is pi over 4. So it is going to be negative 1. Okay. I have run out of space, so I'm going to erase. All right, so now let's find our asymptotes. So our asymptotes, we can go back and look at the formula just in case we forgot it. It is x is equal to c over b. We just found c over b is negative 1, so I'm not going to actually do that calculation again. We don't need to do what we've already done. Plus pi over 2 absolute value b times k, where k is an odd integer. So again, we have x. Oops. So x is equal to, we know c over b is negative 1. We just did that calculation. Plus pi over 2 times pi over 4 times some value k. We're going to say k is 1 this time. So, so this is when k is 1. So I'm not going to put times 1. We know that when we multiply times 1, we get 1. So I get negative 1 plus, we need to do this calculation though. So 2 times pi over 4 gives me pi over 2. So I get pi over 2, which is equal to 1 plus pi times 2 over pi, crosses out. So this is negative 1. So x is equal to negative 1 plus 2, which is 1. So when k is 1, x is equal to 1. So I need another one because we already, did I do my period? I think we did our period. I hope I did the period. The period is 8. So I need to be 8 meters long, or 8 units long. So let's do it now with k equals negative 1. That's nice to do, right? So x is equal to negative 1 again, and we already know this is going to be plus 2. This time I'll multiply it times 1, negative 1, right? Because we've already done this calculation. It's going to be the exact same every single time, and I just know I need to multiply by that k factor. So I get negative 1 minus 2, which is negative 3. So that still does not equal 8, so I need another one. So let's do it when k is equal to 3. So I get x equals -1 plus 2 times 3, which is -1 plus 6, which is 5. So the distance from 5 to -3 is 8. So that gives me my 1 full period. So I have that 1 full period. Now let's see, what else do I need to graph? We have our asymptotes. Let's find a relative minimum and a relative maximum. Okay, so we know again that our relative minimum and maximum can be found with negative absolute value of A plus D, but we don't have a D, so I'm not going to put that, and positive absolute value of A. So our A is 2, so we can either have -2 or +2. And so again, A represents represents our height, and so are the relative minimum or maximum. So we're talking about y values, so I need to figure out what my x values will be. So I am going to do that. I am going to use 2. I'm going to say 2 is equal to 2 secant pi over 4x plus pi over 4, and I want to solve. So again, I'm going to divide both sides by 2, and I get 1 is equal to secant pi over 4x plus pi over 4. And I want to ask myself, when I look at the unit circle, where, oh where, does it equal to 1? Well, one of the places that it equals 1 is 0. So we'll set this section equal to 0 so we can find out what x could be. So we'll say 0 is equal to pi over 4x plus pi over 4. Subtract pi over 4 from both sides, and I get negative pi over 4 equals pi over 4x. Divide both sides by pi over 4. Oops, not negative, but just plain old pi over 4. And I get x is equal to -1. So one of my values will be, I've run out of space again, but I'll try to write it here, would be at -1, 2. Okay, so let's find when it's at -2. Okay, so we have -2 is equal to 2 secant pi over 4x plus pi over 4. Divide both sides by 2, and I get -1 equals secant pi over 4x plus pi over 4. Then I ask myself, where on the unit circle is secant equal to -1? Well, it's equal to -1 at pi. So I want to take this section here and set it equal to pi, because I want my x to come out to equal to pi. So this is pi over 4x. And of course, there's 1,000 ways to do this, guys. This is just one way. Calculator is another way. I want that equal to pi. So I get pi over 4x equals pi minus pi over 4. That's going to give me pi over 4x is equal to 3 pi over 4, and then I'm going to divide both sides by pi over 4, and I get x equals 3. So my other point is going to be 3, -2. So now we can graph. So let's get to graphing. So again, I went ahead and sloppily made this. Again, the calculator is definitely the best. I'm using my fingers and it's difficult, but I have my asymptote at x equals -3, x equals 1, and x equals 5. I believe those were the asymptotes that we found. And this point is, I believe it's -1, 2, if I remember correctly. And then this point down here is 3, -2. And then of course I just test some values to see if I'm going up or down. And for this one it's up, and this one is down, and this is my graph, one period goes 8 meters long, is a, not meters, I'm sorry, units, 8 units long. So this is one period of my function graph, and I hope that this helps.